Okay, so it's been a while since we talked about Lewis structures, but it's very simple. For Lewis structures, we are drawing what the atom looks like by drawing the valence or the outside electrons. And to do that, we just need to find the element, okay? And we need to count the electrons, or sorry, the boxes in that row. Okay, so F is in the second row, and we're just gonna count the boxes till we get there. So box 1, 2, 3, 4, 5, 6, 7. So F is going to have 7 dots around it, 7 valence electrons, and that's how you draw the Lewis structure for F. Okay, pretty simple. All right, so let me give you guys about a minute or so. I want you guys to do the same thing. Draw the Lewis structures for H, Br, and Cl. For Br, there is something that you need to keep in mind, so just a little heads up about that. You might want to look back at your notes about what you need to know for Br. But let me give you guys about a minute or so. Try it out. Check with the person next to you, and then we'll go over it together. Alrighty, guys, let's go over the remaining 3. So let's start with H. If you guys take a look at H, it's right here at the top left. It's box number 1 in its row. So H is going to have 1 valence electron. Okay, so let's jot that down underneath the Lewis structure, that H has 1 valence electron. All right, let's go to Br. Now, Br is the one that I told you that you're going to want to keep an eye out for, because Br is right over here. So we're going to count 1, 2. But if you guys remember from what we learned in Unit 1, we're going to skip this middle section, groups 3 through 12. And then we go 3, 4, 5, 6, 7. So Br will have 7 valence electrons. And let's jot that down as well. So Br has 7 valence electrons. Okay, and hopefully you guys can kind of see the pattern. If they're in the same column, they have the same number of valence electrons. So Cl will also have 7. Okay, so that's the review for Lewis structures. We will need to know how to do this for the new content, but any questions on these first couple problems? Should be pretty easy. Just count the boxes from left to right. All right, so these are kind of like the pictures for individual elements, but today we're going to learn how to draw molecules when these elements combine together, okay? So let's get into it. So I want you guys to write down the title of the lecture. It's called the Octet rule. And if you guys are familiar with just the prefixes for things, octet means 8, right? Like an octopus has 8 arms. An octagon has 8 sides. Well, we're going to be talking about the number 8 quite a bit for the rest of the unit. We're going to be talking about something called the octet rule. So think of the number 8 because that's the one that we're going to be counting up to. All right, so let's talk about what the octet rule is. Now, we talked about how different elements have different valence electrons, right? However, atoms, they don't want to stay the way that they are. They want to complete their valence or their outside shells. And they do this by forming something called a covalent bond. And I want you guys to write down this part that I highlighted. Okay, so atoms will form things called covalent bonds, and they do that by sharing electrons. Okay, so these atoms, they will share electrons with one another. And the reason why is they want their outside shell to be complete. And the way that they complete it is they share electrons with one another so that they can complete one another. Okay, so today I'm going to teach you guys how to draw these covalent bonds, and we're going to jump right into a problem because I think that's just the best way to learn it. So what we're going to do is we're going to take a look at Cl, which is what we did for our example. So I want you guys to look at this chemical. This chemical is Cl2. It's made out of 2 chlorines. So we're going to draw 2 chlorines next to each other. So I'll color code them. We'll have red chlorine and blue chlorine. Okay, since it's Cl2, there's 2 of them. And if we look back at our warm-up problem, how many valence electrons does chlorine have? Yes, 7. So this guy is going to have 7 valence electrons. So we're going to draw 7. And then this guy right here is going to also have 7. Okay, so each chlorine has 7 valence electrons. Okay, so they each have 7 valence. Okay, everybody good so far? Just there's 2 chlorines in Cl2, and each of them have 7 valence electrons. All right, now we talked about how today the lecture is called Octet rule, which means 8. And what the Octet rule is, it means that pretty much every or most elements they want to have 8 valence electrons. Okay, because 8 is the number where they fill up their outside shell. And that's why we call it the Octet rule. It's because most elements, I'll tell you the exceptions, but most elements want to have 8 valence electrons. So chlorine has 7, but it wants to have 8 valence electrons. Okay. So chlorine has 7 valence electrons, but it wants to have 8. And so what's going to happen is they're going to form something called a covalent bond, and they do that by sharing their electrons with one another. So you guys can keep your picture the way it is, but I want to help you guys visualize a little bit. So what's going to happen is these 2 chlorines are going to get super duper close to one another. And what's going to happen is, you see these 2 electrons, right? They're going to share them with one another. Okay, so these 2 electrons are going to be shared. So what that means is they're going to be moving in between them. So this one can go here so that it looks like chlorine has 8. And this one can also go here so that this one also has 8. So if we kind of covered up this chlorine right here, this chlorine has 8 valence electrons. And if we covered up this one right here, this chlorine looks like it has 8 valence electrons. That's what it means to have a covalent bond. They just kind of share electrons together. Now, this is a little bit kind of annoying looking to draw. And so instead of drawing the electrons being shared, what we do is we draw a line in between the 2 chlorines. Okay, and this line right here, if you guys want to label it, this is called your covalent bond. And it represents 2 shared electrons. Okay, and there you go. That's what Cl2, this molecule, looks like. Cl2 looks like 2 chlorines next to each other, and they are sharing 2 electrons, which we represent with one line. And that's pretty much what we'll be practicing for the rest of the class period, just practicing how to draw them sharing their electrons. Yeah. If they had like 6 valence electrons each, we're gonna talk about that next time. Yeah. Any other questions? Hopefully it's not too complicated. Just know that they're going to share electrons, and we represent that by drawing a line. All right, so let's go through a couple more rules that'll kind of help you guys draw these structures, because this one's pretty easy because it's only 2 elements. But as you guys know, there are molecules that have a lot more elements inside of it. So let me give you guys a couple rules that'll make things easier. So we already talked about octet rule. You guys don't need to write this down. It's that atoms want to have 8 valence electrons. Now, there is one very big exception, and it's this one right here, hydrogen. Hydrogen can only have 2 electrons. Okay, so make sure you guys write that down. Hydrogen can only have 2 electrons. Another way that you guys can think of it is hydrogen can only have 1 line next to it. Okay, so hydrogen can only have 2 electrons, so hydrogen can only have 1 line next to it. Because if you remember our example earlier with the chlorines, remember how chlorine had 6 of these dots next to it and the line, right? It's because it wants 8, but hydrogen cannot have any dots on it. It can only have 1 line next to it. Okay, so hydrogen cannot have dots. But that's what I mean by it can only have 1 line next to it. That's the key exception for the octet rule. All right, so as we draw some more complicated structures, here's some tips that you guys can write down that'll help you guys out. First, hydrogen is always going to go on the outside of the molecule. And the reason why is it can only make a connection with 1 element. And so it's going to always go on the outside. Can't go in the middle, because middle is where they connect with more than 1. So hydrogen always goes on the outside. And the second tip that'll be very helpful is that if you have carbon or silicon, those are going to go in the middle. They're like the most extroverted elements. They want to be in the center of the molecule so they connect with as many other elements as possible. Okay, so those are the two, I guess, main tips that'll help you guys out as you guys are drawing your structures. Remember, hydrogen always goes on the outside, and carbon and silicon tend to go in the middle of the molecule. And then we talked about this earlier. If you draw a line next to an element, it means that it has two electrons shared with the one connected to it. I'll give you guys another minute to copy that down. Okay. All right, let's draw our next molecule. So we are going to draw the structure for HBr. We'll talk about this next part right here in a second, but we're going to draw HBr. Now, before we start drawing it, there's some steps that we can follow to make drawing these a lot easier. The first thing we want to do is we want to count all the valence electrons. So if you take a look at HBr, I want you guys to write HBr on your paper. And what we're going to do is we're going to count how many valence electrons we have to work with, okay? So let's take a look at the periodic table. Or actually, we did this in our warm-up. How many valence electrons does hydrogen have? 1. Okay, so we're going to write down that hydrogen has 1 valence electron, okay? Okay, let's take a look at bromine. How many valence electrons did bromine have? 7. Okay, what that means is, for this molecule, we are going to be drawing 8 valence electrons. Okay, so we're going to be drawing 8 valence electrons. And we're going to do that by using the lines and the dots. Okay, so that's the first thing we want to do. We want to count the valence electrons. All right, next thing we're going to do is we're going to connect all the atoms. So we're going to write down the elements. So we're going to write H and Br. And we're going to connect them because they're one molecule, so they're connected together. So let's draw a line to connect them. All right, so if we draw a line, do you guys remember how many electrons does this line represent? 2. So when we draw a line, we used 2 electrons. Okay, so we had 8. We used 2 of them. So now we have 6 that we need to still draw. Okay. And we just want to make sure after that we draw some dots or lines so that all the elements have 8 and hydrogen has 2. So if we take a look at hydrogen, hydrogen has a line next to it, right? What that means is hydrogen has 2 electrons. So hydrogen is happy. We don't need to do anything else to hydrogen. Okay. All right, but if we take a look at bromine, how many electrons does bromine have right now? 2, because it has a line next to it. So that means it still wants to get to 8. So we're going to draw some dots on it in order to get it to 8. So we're going to draw a dot. So that's 3, 4, 5, 6, 7, 8. And now bromine is happy because it has 6 dots and a line, which will total up to 8. Which is perfect because we had 6 electrons still left to draw, and we drew 3 dots. Okay, and there you go. That's what HBr looks like. So just follow these steps. In order to draw the molecules, you count the electrons first, you connect them, and then you just add dots until everybody is happy. Okay? Until hydrogen has 2 and bromine has 8. Yeah. Yeah, the orientation doesn't matter. So just I want to clarify, make sure I'm saying this. You mean something like this, right? Yeah, that's totally fine. This is absolutely correct. The only thing I'm looking for are the connections the same? Good. Any other questions? All right, let's try a couple more. Oh, actually, before we do that, we need to define a couple things. Shared and lone pair. So basically, shared electrons are basically how many electrons went into making the lines. So if you have one line, that means you have 2 shared electrons. And lone pairs are the dots. And so there are 6 dots. So you have 6, bless you. So you have 6 lone pair electrons. That's what that means. Shared electrons are the ones that create the lines. Each line is 2 electrons. So you have 2 shared electrons. Lone pairs are the dots. There are 6 dots, so 6 lone pairs. Okay. All right, let's move on to the next molecule. All right, so we've been looking at molecules that are just two elements, which is pretty easy because you just make one connection. But it gets a little bit trickier with molecules that have more than two elements. So here we're looking at H2O or water. And so we're going to draw the structure for water. So first thing we're going to do is we're going to start by counting the valence electrons. So I want you guys to take about a minute. I want you guys to count how many valence electrons do we have to work with in H2O. I'll give you guys a minute to do that. Look at your periodic tables, and then you can check with the person next to you. But take a minute, count the valence electrons. How many electrons can we draw in this molecule? Oh, so if you take a look at H2O, it has H. How many valence electrons does H give you? There's one, but there's two of them, so you got two from the H's. So H2 gives you 2 electrons, so 1 plus 1. Okay, let's take a look at the oxygen. How many valence electrons does oxygen give you? 6, yeah. 1, 2, 3, 4, 5, and 6. So 1 plus 1 plus 6. So H2O, the amount of electrons that we have to work with are 8. Okay, so we got 8 valence electrons. Okay, so that's the first thing we do. Next, we have to organize the molecule together. So if you guys remember, H always goes on the outside of the molecule, right? Which means on the inside, we are going to put oxygen. So you guys can orient it again however you like. I'm going to do it in a line like this. So H goes on the outside and O goes in the middle. But if you wanted to do like up and down, that's fine as well. If you want to do it diagonal for whatever reason, that's fine as well. Okay, as long as H is kind of surrounding the oxygen. If you wanted to do it even like this, that's fine as well. It doesn't matter as long as the H's are somewhere on the outside of the molecule. Okay? Everybody good with that so far? All right. So let's connect the atoms together. So if you guys remember, O is in the middle, which means H is going to connect with the O. So I drew one line. And if I draw one line, how many electrons am I using? 2. So I drew a line. So now we use 2. So we have 6. Okay, we got to connect this one as well. So I draw another line. That's 2 more electrons. And now I have 4. Okay. All right, and then now we just need to make sure that all the atoms have 8 and hydrogen has 2. So if we take a look at this hydrogen, it has a line next to it. So this guy already has 2. This hydrogen is happy. If you take a look at this hydrogen right here, it also has a line next to it. So it's also happy because it has 2 electrons. But if you take a look at oxygen, how many electrons does oxygen have right now? 4, yeah, because it has 2 lines next to it, right? It has 1 line on the left, 1 line on the right. So currently, oxygen only has 4. Okay, but it wants to get to 8. Okay, which is fine because we still have 4 electrons to use. So we put 1, 2, 3, 4 dots on it. And now oxygen has 8. And everybody's happy, and we used all of our electrons. So there you go, guys. That's what water is going to look like. You got an oxygen in the middle, and then 2 hydrogens surrounding it. Okay? And again, the orientation does not matter. If you drew this, that's fine. If you drew this, that's fine. As long as the oxygen has 4 dots on it with 2 lines, and the hydrogens each have 1 line. All right, any questions on that one? It is going to get a little bit more complicated. We're going to slowly add atoms to it, but that's the general gist of it. All right, you guys think you could try one on your own? Okay, let's try one on our own. Oh, before we do that, shared and lone pair. Okay, in this molecule, there are 2 lines. So if there are 2 lines, that means we have 4 shared electrons. And there are 4 dots, so we have 4 lone pairs. Okay, so if you guys want to think about it, the shared electrons are the lines times 2, and then the lone pair is just how many dots there are. Alrighty, guys, let's do the next example, and I'll have you guys do this one on your own. You can work with the person next to you. But I'll give you guys about 3 minutes. I want you guys to draw the structure of CH4. Okay, CH4. Okay, a little bit more atoms in the molecule now, but refer back to the rules that you copied down. It'll be helpful. CH4. Take about 3 minutes, and then we'll go over it together. Okay, so we got 8 valence electrons, 4 from the carbons, and then 4 from the 4 hydrogens. What we're going to do now is we're going to connect them together. Now, if you guys remember the rules we went over, which element is going to go in the middle? C, great. So you're going to put C somewhere in the middle, and then H is going to go on the outside. Now, I'm going to first show you what doesn't work, okay? So you don't want to do this, okay? Okay. The reason why you don't want to do that is because H goes on the outside, right? But that means every single H is on the outside. But if you organize it like this, is this H on the outside? No, it's not. Is this H on the outside? It's not. So that's why this does not work. H has to go on the outside of the molecule. So the way you want it to orient it is C in the middle, and the H's are going to surround the carbon, okay? And if you got that, great. If you got this, that's totally fine. Again, you're not familiar seeing these, and so this is a good guess, okay? Now, again, you can orient it however you like. You can do this little cross shape. You can do an X shape if you want, whatever you want, as long as the C is in the middle and the H's are surrounding the carbon, okay? Okay, from there, it's very simple. We're going to draw lines to connect the elements together. If we connect this carbon and hydrogen, how many electrons did we use? 2. Okay, hydrogen is happy now. So we're going to connect this right here. That's 4. That's 6. And that's 8. And we're all done. Okay, so you should have something that looks like this. Okay, so just keep that in mind. H can only make one connection, so it can only connect to one other element. That's why this structure doesn't work right here. Okay, you don't need to put them straight in a line. You can put them up, down, left, right, diagonal. Okay. All right. So let's look at the shared electrons. How many shared electrons do we have here? 8, yeah, because there are 4 lines. So you're going to have 8 shared electrons. And how many lone pairs do you have? 0, no dots, so it's 0 lone pair. Good. All right, I think we have a couple more to do. Let's move on to the next one. Okay, so next one is very, very intimidating looking, right? CH3, CH2, CH3, okay? Now, this is actually really easy, and I'm going to show you guys how to break it down. But before we do that, let's start by just counting the valence electrons. So I want you guys to take a look at this. Use your periodic table. I want you to figure out first the valence electrons. Let me give you guys about a minute to do that, and then I'll show you guys how to draw the structure for this. Okay, so count the valence electrons first. All right, did everyone get 20? 20? Yeah, so carbon is 4, hydrogen is 1, so each of the carbons give you 4, and then each of the hydrogens give you 1, add up to 20. All right, so this is a very ugly molecule, right? A lot of different elements, and why are the elements split up? Okay, now, I think I mentioned this to you before, but if the elements are split up like this, you guys see how there's a C here, a C here, and a C here, right? What that means is it's the person whoever wrote the formula is trying to tell you what the molecule looks like. So if you guys take a look, there's a C on the left side. I'm going to color code them, so I'll make this the red C. That means there is a C on the left side of the molecule, and it is connected to 3 hydrogens. Okay, and so 3 hydrogens are going to surround that carbon. Okay, that's what this kind of formula is telling you. If you ever see elements split up, it's telling you what the molecule looks like. Okay, let's go to the second C, the one in the middle. I'll make that the blue one. Okay, and then this one is in the middle. So C is in the middle, and there are 2 hydrogens connected to it. So there's going to be a hydrogen surrounding it like that. And then from there, you guys can kind of see what the molecule is going to look like, right? And then the last carbon right here, I'll make that one black. Okay, and this one on the right is going to be C, and there are also 3 hydrogens around it. So hydrogen, hydrogen, hydrogen. Okay, so if you have something like this, it's actually a lot more helpful because it tells you what the molecule already looks like. All right, and then from there, let's connect the elements together. If you guys take a look at the hydrogens on the left side, they're connected to this C. So 2, 4, 6, In the middle, you got 2 hydrogens connected to the carbon. So that's 2, and that's another 4. So we got 10. And on the right side, the hydrogens are connected to the carbon like that. And then we just kind of combine everything together. And that should be 20 valence electrons because there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines, which is 20 electrons. And so that's what this molecule looks like. So I know it looks very intimidating, but it's actually a lot easier to draw if you have them split up like that. All right, any questions about that one? You guys can do the shared and lone pair on your own if you like. The shared is 20, and there's no dots, so it's 0 lone pairs. Okay, before we finish up, I do want to give you guys a little bit more information about the exam. So your exam will have these drawings, but I want to show you guys what types of pictures you guys will have, or what type of problem you'll have. So there is one last thing that we're going to add on to this. So next time we meet, we will finish up this concept. There's something else that we need to add on. But I want to show you guys generally what the problems on your exams look like. So if I scroll down right here, on your exam, you'll get a chemical formula, same thing that you guys have been seeing. So you'll balance it, and then you'll be doing what we learned today. You're going to draw the structures for all the compounds in the reaction. So you see how there's 4 chemicals inside of the equation, right? You're going to draw 4 different structures. And then after that, you're going to do stoichiometry. So yeah, it's like a big mega problem, just kind of combining everything that we've learned so far. Yes?
It's probably
okay, if you remember, let me know, okay? Yeah, but basically it's a mega problem. We're kind of combining all the things we learned. We're going to have the structure, you're going to have balancing, you're going to have stoichiometry. There's also going to be a ty, ay, percent y on there. If you guys take a look on Canvas, I already put the review for the exam up. And if you guys remember, I literally copy and paste from this onto the exam. I just changed the numbers. And so that's what you'll have. You'll have structure, you'll have stoichiometry, and then you'll have ty, ay, percent y. Go ahead. Yeah, so next time we meet, we're going to learn the last component that adds on to this. And then after that, we're going to be practicing for the exam. It's one problem. Yeah, so if you look at the review, I actually put an example of what a full credit answer looks like. So you'll have sorry, let me zoom in a little more. You'll have something that looks just like this right here. And this is including the answer. Okay. Yeah. You guys can't do the review yet, just letting you know, because there is one other thing we need to learn. You guys probably see it right here. There's 2 lines. What does that mean? We'll talk about that next time. But that's what your exam will look like. No surprises. Okay.